All right, hi everyone. How you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. All right, so first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy where everything is, which is India's largest online learning platform. And on this particular channel, every concept of physics, chemistry, and maths are being taught to you completely in English. This is a series that I host for class 12 students. This is meant for their quick revision of important topics of class 11th. So this is the topic that we are covering right now is SHM. This is part 4 of the quick review of SHM. Okay, and before we get started with today's lecture, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. Now, for almost past 8 years now, I've been teaching physics for the IIT JEE Mains and advanced examinations. Now, most of my experience so far, 7 years of experience was in offline setups. For past 1 year now, I've been teaching online here with you guys. Okay. So as a student, I myself was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exams that I took. Now I also qualified at the NTSC stage 2 as a student and I was in the top 1% in the NSCP exam as well. Now I've already coached many students to top ranks in the IIT JEE exams in through this offline teaching, and now I hope to continue doing that here online with you guys. So any student who is confused about how to go about their preparation in this new era of COVID and lockdown. So a wonderful opportunity for you guys is that you can continue with your preparations just like you would have wanted by getting yourselves the Unacademy subscription. Now, this subscription will give you benefits like live classes where you get to interact with your educators on a regular basis. Then you, of course, also have live polls and leaderboards in these classrooms, which keep these highly interactive and very efficient. Then you have test series and analysis sessions on a regular basis again, which is very important for a competitive exam like IIT JEE. So you need to be constantly aware and you need to be tested repeatedly. Okay, so in order to improve your performance, so I think that feature helps you with that. And of course, the best feature of all is the live doubt clearing sessions that you get here. So for all Unacademy Plus courses, every fourth session is supposed to be a compulsory live doubt clearing session. So after every three teaching sessions, you have one session which is dedicated entirely to your doubts, so where students may ask any kind of doubts that they have regarding their concepts or problem solving. Any problem that they are facing will be sorted through these sessions. Of course, on top of all these benefits, you get the chance to study from the topmost educators from all across the country from the comfort and safety of your home. I think that's another huge advantage right now, and that's a wonderful opportunity. That's something that we as students never had. Okay, so I think all students must look to utilize this chance. So how do you avail these benefits? The first step involves you to install the Unacademy app. Now, the moment you do that, you will be able to avail a lot of free features that the Unacademy app offers. So there are free courses that you can directly enroll in just after installing the Unacademy app. Also, there are special classes. So all these special classes are completely free of cost. So any student who has the app installed can attend these special classes absolutely free of cost. And then, of course, you can take part in quizzes like the ones that we have every Tuesday. So all these free features you can simply benefit with just after installing the app. You don't even need to buy any subscription for this. All you need to do is install the app and unlock all these benefits with the help of this code RD Live. Okay, that is all it takes to unlock these benefits. Now, this will give you a flavor of how your preparation is going to be with your plus subscription. So once you're convinced and once you finally decide to get yourself the plus subscription, then these are the steps that you need to follow. So you can go to the plus section of your app, select your goal as IIT JEE, and click on the get subscription button. Okay, and when you click there, you will realize you are redirected to the payment page where you will find a box which says, do you have a code? So there you can enter this code RD Live. So this code will give you a 10% off on all your subscription fees. Okay, and of course, now you can choose from two kinds of subscriptions, plus and iconic. And the fees of both these kind of subscriptions are mentioned below. Now you will also realize when you click on proceed to pay, then you can even choose a lot of no cost EMI options to break this payment into more suitable payment plans, which will definitely reduce the burden or pinch of the payment. All right. Now, those of you who don't know what the iconic subscription is, so this is a new offering by Unacademy. So this subscription essentially takes your JEE preparation to the next level. And how does it do that? So from our team of experts, you are allotted personal coaches. These personal coaches will personally mentor you throughout your IIT JEE journey and closely monitor your performance. Along with that, you also get benefits like you get to attend a lot of IIT JEE workshops. You receive timely expert guidelines. Then you have a study planner, and of course, you have regular test analysis sessions. So with all these features, you will trust me power through your JEE preparation. So hello Motilal, hi AP, how are you guys doing? Now, students who have just come into class 11th and who are confused about what to do about their studies for the next 2 years, now you guys can opt for one of these combo subscriptions. So, Unacademy is also offering you combo subscriptions. These subscriptions will take care of all your study needs, be it your class 11th CBSE, be it your class 12 CBSE, your boards, your IIT JEE preparation for mains, IIT JEE preparation for advanced. So, everything taken care of by these combo subscriptions. There are four kinds of combo subscriptions now available for class 11 students. So these are as follows. So the first combo offers you the iconic subscription for your IIT JEE preparation and the plus subscription for your CBSE preparation. Now this combo starts at around 4,600 a month. Then you can go for a combo which offers you the iconic subscription for all IIT JEE and class 11th and 12th. This combo starts at around 5,500 a month. Then of course you have another combo which offers you the plus subscription for all three. So this combo starts at roughly 3,000 a month. And finally, you have a combo which offers you the plus subscription for IIT JEE and Iconic for CBSE 11th and 12th. So this subscription comes to about 3,900 a month. So again, depending on what kind of need you feel. Hi, Amod Kumar, how are you? So depending on your preparation needs, your preparation levels, and your aims, you can choose an appropriate combo and leave all your study worries behind. Next, these are the upcoming tests in January. So the next Unacademy Combat is going to happen on 31st of Jan. Do not miss that one. The next race competition is going to happen on the 24th of Jan. Now, AIM Advanced 2021 exams are happening every Saturday, and you have unique DPP discussions which are going through every Monday to Thursday. Okay, so make sure you are attending all these. Now, the students who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. So when you connect with us on the Telegram app, this will ensure that you are getting all the timely notifications of all the sessions and lectures happening here on this channel. Okay, so that you're not missing out on any of the amazing content being provided to you through this channel. Now, why don't we get started with our review of the topic that we were discussing, which is SHM. So this is part 4 of the quick review. Now, until last time, we studied the basics of SHM, the equations of SHM, the energy during SHM, and how to analyze different kinds of SHM. Now, today we will shift our focus on superposition of SHMs. Suppose a body is subjected to 2 or more SHMs, then what is the resultant motion is going to like? That is going to be our focus today. So the analysis of motion of any object resulting from a combination of several independent SHM at the same time can be done using the superposition principle. Okay, so you will realize that you already know that F net acting on any body which governs the motion is nothing but summation of all the individual forces, correct? Okay, F1, F2, F3. Now imagine if each of these forces would cause one SHM each. So you realize the net acceleration, you would realize d2x over dt2 would be the sum of the accelerations caused by individual forces, right? So I can rewrite that as this. So similarly, essentially what I'm trying to say is that if you have a lot of forces acting on an object, then the resultant motion can be obtained by simply superimposing all the individual motions caused by individual forces. Okay, so that's the entire logic of this superposition. So this principle states that whenever or several oscillations are added, the resulting displacement at any time is nothing but the net sum of all the displacement due to individual oscillations. Okay. Now, for analysis of superposition, you have two methods. One is called the analytical method, and another is the Phasor method. So we will take a look at both the methods one by one. Okay. So let's talk about the analytical method first. So hello Mahi ji, how are you? Okay, so in analytical method, I'm going to assume that the resultant motion is supposed to be sum of two SHMs, one SHM represented by this equation, another SHM represented by this equation. Now, for the sake of simplicity, we have taken the the amplitudes of the two SHMs as same. Okay, so you realize all you can do is you can apply the formula for sine A plus sine B. Okay, so that gives you 2 sine A plus B by 2 into cos of A minus B by 2. So you realize the resultant motion is going to come like this. Now, if I consider a special case, so where the omega 1 is equal to omega 2, then you get this equation, and this you realize would be an SHM. This motion would be an SHM, where this term would represent the new amplitude. Okay, this term would represent the new amplitude. And this term, of course, is representing this is the frequency and this is the initial phase. Okay, so this is the phase of that SHM. So in this particular special case where omega 1 equals omega 2 and the amplitudes are equal, the resultant motion is in fact SHM only. Okay, otherwise the sum of harmonic motions, harmonic functions is going to be harmonic. So it might be oscillatory, but it might not be SHM every time. Okay, this particular case only results in an SHM. Okay, so that is one method. The another method is the Phasor method. Now that's a more generic approach. So using phasors, you could have added the two SHMs and found the resultant motion. So in general, if you can imagine that there is one SHM that is, so let's take a very generic process. So A1 sine omega 1 t plus phi naught 1 and x2 would be equal to A2 sine of omega 2t plus phi naught 2. Let's imagine I have a very generic case of two very different SHMs. So you realize every SHM now can be represented by a phasor. Okay, so for this I can I can consider a phasor which has a length A1, and at any time t, this is the phase, which is omega 1 t plus phi naught 1. Right, and the second phasor, of course, would be something like this, having length A2, and the phase would be given by this. So you realize at this instant, what is the phase difference? Delta phi. So if I talk about the delta phi, so what I realize is delta phi is going to be omega 2 minus omega 1 t plus phi naught 2 minus phi naught 1. Okay, this is going to be the delta phi. Now, once you know the phase difference between the two phasors, now you can use vector summation. Okay, as I told you, phasor is nothing but a vector which is rotating. Okay, so when I'm adding these two phasors, the resultant would be simply the vector sum of these two. So I could have had the resultant phasor as this. Somewhere I could have had the resultant phasor which has a length of AR. Okay, so I hope that is visible. Yeah. So if I wanted to find the length of the AR phasor, so what you will realize is the length of the AR phasor would be simply, I am adding two vectors which have an angle phase difference of delta phi. Right, so can I say that AR square would be equal to A1 square plus A2 square plus 2A1 A2 cos of delta phi. Okay, I'm simply using the law of vector addition. So that will give me the AR vector, okay, the resultant amplitude of the phasor. Now you realize this will obviously contain a term of time. So this is not an amplitude which is fixed, and hence the resulting motion will not be SHM. The SHM is supposed to have a fixed amplitude. In this particular case, the AR, the resultant amplitude, keeps varying with time. Please note that. So the resultant will not be SHM. It will be oscillation, but not SHM. Okay. Next, if I wanted to determine the phase of this, so you already know what this angle is going to be. Okay, if you remember your laws of vector addition, So if let's say this angle was alpha, then you also know tan of alpha would have been a2 cos delta phi sine delta phi over a1 plus a2 cos of delta phi. So this is the method in which you could have found the general resultant of the superposition of these motions. But please note that this motion is not going to be SHM. The only way where the resultant motion is going to be SHM is if you do not have the time term, right, in your amplitude. So to remove the term of time in your amplitude, what is needed is that omega 1 should be equal to omega 2. If that happens, then this term becomes 0. Okay. So you will realize in that case, the motion will be in fact SHM. Okay. If omega 1 becomes equal to omega 2, then the motion will be SHM. Okay. So let's make a note for that. For motion, the SHM condition would be omega 1 equals omega 2. Okay. Otherwise, the motion would be oscillatory, but it won't be SHM because it doesn't have a fixed amplitude. Okay. Now, the moment you do that, now you realize this term is fixed. This term is fixed, correct? This term is fixed, so your amplitude is fixed with time, AR, the resultant amplitude, and you will also realize that this alpha is also fixed. So in that case, again, you could have found both the values and predicted what the resultant motion would have been. Okay. So again, as I said, this is a very general method with which you could have added any kind of motions. Okay, but in our analysis, we will only focus on this kind of motion because only under this condition the resultant motion will be another SHM. Okay. Next, let's talk about this. The displacement of a particle executing periodic motion is given by y equals 4 cos square 0.5 t into sine 100 t. So the given expression is composed by minimum of how many SHMs? Okay, so that is the question. So how many SHMs will a superimposition of how many SHMs would have caused this kind of motion? Again, this is a periodic motion, not an SHM. Okay, this resultant motion is periodic, but not SHM. Okay. So what do you think the answer is going to be? So think about this. Think about this. Try and let me know the answer. Okay, AP says B. Okay, okay. How about others? Any other thoughts? Okay. Yes, very easy indeed. IG also says B. Okay, okay, okay. So yes, B turns out is the correct answer. Well done, you guys. So listen. The trick for this is you will remember when we added two SHMs, you have a term which has sine and cos multiplied. Okay, that is when we added two SHMs. Suppose if I added three SHMs, then I would have added another term to this. So I would have had multiplication of three such terms. Okay. So what you do is you see how many terms of cos or sine have been multiplied here. So here three terms have been multiplied for cos and sine, right? So if three terms are multiplied, then that is the superposition of three SHMs. Again, if you would have had here sine square, then that would have resulted from superposition of four SHMs and so on. Okay, so please remember that. So the correct answer is 3 SHM, and the trick for that is to see how many powers of cos and sine are involved in the expression. Okay, the number of powers is equal to the number of SHMs that have been added together. All right, so that one was easy, of course. So let's try another one. So in this particular case, you have been told that now two mutually perpendicular SHMs are added. Okay, so a particle is subjected to two mutually perpendicular SHMs. Okay, such that the x and the y coordinates are oscillating like this. So x coordinate varies like this and y coordinate varies like this. the path of the particle would be. So you have your options there. What do you think is going to be the path of the particle? Okay, again, this should be easy. Now you will also realize one thing. So after I tell you the answer for this, I will tell you another thing. Okay. So let's see you guys try this. So what do you guys think about this? Hello Shivam, how are you? So tell me, what do you guys think about this one? How is the path of the particle subjected to these two SHMs is going to look like? Okay, so try this and let me know. Okay, can I have an answer? What happened? This is an easy one, guys. Okay, what is taking so long? Okay, so I guess you guys are confused about mutually perpendicular systems. Is it? So I'll tell you how you. Okay, AP says A ellipse. Yes, that is the correct answer. That is in fact the correct answer. AP, well done. Okay, Mahi, you also gave the right answer. So of course. If you look at the equations carefully, this says x equals to sine omega t. Okay, and y equals 4 sine of omega t plus pi by 2. Again, a very similar question was asked in JEE Advanced. Okay, a very similar question was asked in JEE Advanced, where you were told a similar variation of the x and y coordinates was given, and the trajectory was asked, and questions were asked related to the trajectory of the particle. Okay, so what you realize is from here you can write that sine omega t is x by 2. That's my equation number one, and from here you can write, so this term can be written as cos of omega t. Correct? This is nothing but cos of omega t. From here you could have written cos of omega t to y over 4. Now all you need to do is square both the expressions and add them together. So if you square 1 square plus 2 square, what will that give you? That would have given you the equation x square by 4 plus y square over 6 equals 1, which is the equation of an ellipse. Okay, so yes, the correct answer is that superposition of these two will render a elliptical path. Okay. Now that should again remind you, if you go back to your analogy of circular motion, right? If we go back to our analogy of circular motion, then I want to bring your attention back to something. So initially, you remember we had said that any SHM can be seen as projection of a circular motion, right? So you realize if again I go back to that definition. So imagine here is a particle which is performing circular motion, okay, so of radius a and rotating with the angular velocity omega. Then what you realize was that the y coordinate, right? The y coordinate was given as, realizes that y is a sine of t plus phi naught. Similarly, if you look at the x coordinate, what is the x coordinate? The x coordinate is a sine omega t plus phi naught. So essentially, can I say that circular motion is essentially the superimposition of two mutually perpendicular SHMs of the same frequency, the same amplitude. Okay. So therefore, circular motion is a result of two mutually perpendicular SHMs of same omega, and of course 90-degree phase difference. Okay, it was very similar. Ah, okay, sorry. यहाँ cos लिखना था. Okay, अब ठीक है. हाँ, so ये भी तो SHM ही है. ठीक है. So that is what I can say. So it is very similar to that. Okay. Similarly, I can say that yes, ellipse is a result of elliptical motion would be a result of two SHMs, one in X and one in Y, both of different amplitudes now. Okay. Okay. Now let's move on to the next question then. The amplitude of a vibrating particle due to superimposition of these two SHMs would be. That is what you have to find. So find the resultant amplitude of the superposition of these two. Yeah. Let's see if you can figure this out. Again, what kind of SHM superimposition is this? This is a superimposition of two SHMs with the same amplitude. One. Okay. The amplitudes are 1 and the omegas are C. Correct? So Shivam says A, okay, and AP says C. So if you remember, we studied this equation here, right? Right here. When you superimpose two SHMs, which have the same amplitude and the same omega, then this is the equation that you get. Okay, so please remember that. Now you could have seen that from Phasor also. Okay, all you are doing is for x1 you have this phasor, okay, and x2 you have this phasor. This is your x1 phasor, this is your x2 phasor. The angle between them is pi by 3. The length is 1. The length is 1. So what is going to be the resultant amplitude? AR square is going to be A1 square plus A2 square plus A1 A2 cos of delta phi, correct? Now in special case, if A1 equals A2 equals A, then what you will realize is AR square would be equal to 2A square plus 2A square cos of delta phi. Okay, now you can take 2A square common. This is 1 plus cos of delta phi. Okay, now you will remember what is cos of 2A. It is 2 cos square A minus 1. So from here I can say 1 plus cos of 2A is equal to 2 cos square A. Correct. So if I substitute that, what I get is AR square is equal to 4A square cos square delta phi by 2. Correct. So that gives me the result AR is equal to A cos of delta phi by 2. Now please remember this result. This is a very important result which we use a lot. Okay. We will use this result a lot. Very, very important result. Right. So memorize this. Memorize this. This result is so important that you should memorize this. This will help you in your Wave optics also. When you're talking about YDSE, Young's double slit experiment, and when you're talking about interference, then also you will be using this result, because that is also nothing but superposition, right? So now all you need to do is apply this formula. So all you realize is that a resultant would be 2 into 1 into cos of delta phi. Delta phi is pi by 3, so pi by 3 by 2, so pi by 6. Cos of pi by 6 is of course root 3 by 2, so the answer is root 3. C. Okay, I hope that is clear. Again, let me remind you one last time, remember this result. So whenever you are superimposing two SHMs which have the same amplitude and the same omega, then the resultant is given by this expression. And this is a very important result which we will be using again and again. So you should memorize this. ठीक है भाई, याद कर लो इसे. Okay. Next, again, you have two SHMs x1 and x2, which are given as x1 equals sine omega t and x2 equals cos of omega t, are superimposed on a particle of mass m. The total mechanical energy of this particle is going to be, what is going to be the total mechanical energy? Is what you have to find. So option A, is it going to be 1 by 4 m omega square a square? B, is it going to be half m omega square a square? Option C, is it going to be m omega square a square? Or option D, is it going to be 2m omega square a square? Okay, so hurry up. This is again a very easy one, and you can solve this using many methods, by the way. Yeah. So when do we use superposition methods? If you would remember, when do we use superposition methods? We use superposition methods whenever two motions are mutually independent, or two things are mutually independent. Then we can apply superposition methods, right? So if two things are mutually independent, then the kinetic energy is associated, or the total energy is associated with them, are also independent. Okay. So one quick way, again, there should be A here. One A is missing. So here just add A. Okay, otherwise how will you get the term of A in the answer? That was missed. Question was typed. You add that right. Okay, now try and answer this. Okay, so what do you think is the answer? Again, as I told you, you could have used many logics. You could have even used the logic that whenever you are using superposition, so two things are mutually independent. If two things are mutually independent, then the energy associated with them are also mutually independent, and the total energy would simply be the sum of the individual two energies, right? So that should give you a hint towards the answer of this. अब तो बता दो भाई. So anybody giving me the answer? No one cares, says A. Okay. Okay, no one cares. A is unfortunately wrong. Wrong. Okay. So again, as I said, there are two, three ways of getting to this answer. Hmm. So anybody else? Anybody else wants to try? How about Shivam? Where is AP now? Oh, it's okay. It's okay. No one cares. That's all right. That's all right. Hmm. Okay. So let me tell you. The correct answer for this is in fact C. So I'll tell you. Flat. Okay. Q why? I'll tell you. There are two ways of determining this. One was that you know that if these SHMs are mutually independent, then all you need to do is add the energies of individual SHMs, right? So that was the first method. E net would have been equal to E1 plus E2. So the energy of the first SHM would have been half m omega square a square plus the energy of the second SHM would also have been half m omega square a square, because for both the amplitude is a and the angular frequency is omega. So the total energy is m omega square a square. As simple as that, है ना? इसमें क्या फ्लैट हो गए? ठीक है. Now let's tell you the alternate method of solving this. है ना? We will talk about another method of solving this. Don't worry. Next, you will know that yes, Mahi. So I did tell you that again. Imagine when you are superimposing two phasors of A each, having an angle of delta phi. Okay, so what is the resultant going to look like? Let's see. So for finding the resultant, I can complete the parallelogram, and this of course would be the rhombus, right? So this is going to be the resultant, and I already know now that AR would be equal to 2A cos of delta phi by 2. First, I know this. Second, what I will know is that this angle will be equal to this angle, right? For a rhombus, the diagonal is a bisector of the angles, right? So what is this? This is delta phi by 2. So imagine, if I talk about two SHMs, okay, so if I talk about two SHMs, and let's say this is SHM1, this is SHM1, and this is SHM2. So in general, if I write those equations, if I say that x1 is equal to a sine omega t plus phi naught 1, assuming that this is the general equation that I'm considering. For the second, I will take the equation a sine omega 2 plus phi naught 2. Okay, again the general expression. Now you realize that the resultant has a phasor has a phase which is ahead of phasor number 1 by delta phi by 2, correct? So I already calculated the resultant amplitude, and what is going to be the omega? The omega is going to be the same, right? Because both the phasors are rotating with the same omega, so the resultant will also rotate with the same omega. So can I say x resultant would be AR sine of omega t plus phi naught 1 plus delta phi by 2. That is how you can find the expression for the resultant SHM. Did you guys follow that? What I did? I said that when you are adding two phasors, the resultant phasor would go in the middle. So if it goes in the middle, that means from the first one, it is ahead by in phase by an angle of delta phi by 2. And omega is of course the same. So what I did was, when I have to write the final equation, what I'll do is I'll write AR, the resultant amplitude, and in phase I'll write the phase of one and then add delta phi by 2 to it. Okay. So that is how you can find the resultant equation also. So in this particular case, what was I told? In this particular case, let's say I was told that x1 was a sine omega t. Okay. So x1 equals a sine omega t. Okay. And x2 was a cos omega t, which can be written as a cos of omega t, which I can rewrite as a sine of omega t plus pi by 2. Correct? So what I realized is what is the phase difference between the two? It's pi by 2. Correct? So x a resultant, what would that be? 2a to cos of pi by 4. So a resultant is nothing but root 2a. Correct? So what will be the equation? X would be equal to root 2a, and I will have sine of omega t, so which is the phase of 1 plus delta phi by 2, so pi by 4. This would have been the equation of the resultant SHM. Okay, now once I have the resultant equation, now the energy I can calculate. So this is an alternate method again. So this is the amplitude, this is the omega. What is the energy going to be? Right, so energy is going to be half omega square into root a whole square. So that would be m omega square a square. That is our answer. Okay. Again, follow the methods. Follow both the methods. You should know how to write the resultant SHM. Okay, very important this analysis. So now you know that if you have two SHMs which are given like this, so one SHM given like this, second SHM given like this, then the resultant can be written like this. Okay, where AR would be this. So very important, all these forms. Okay. So delta phi, of course, is the phase difference between the two. Delta phi, of course, is phi naught 2 minus phi naught 1. Correct? So this is applied here. So this would have been the resultant expression for the resultant motion. Okay, and once I have the equation of the resultant motion, then I can easily write the energy. Okay, half m omega square a square. The amplitude here would have been root 2a. Okay, so this is the second method of solving this. Again, with this method, you could have said everything. Once you find the final equation of the SHM, you could have told everything about that SHM, the resultant SHM. You could have told me the amplitude. You could have told me the omega. You could have told me the initial phase. Okay, so that is how you find the resultant motion equation. Okay, I hope everybody followed that. In case there is any confusion, so go through this page one more time, and in case you have any kind of confusion, you let me know. Okay. Okay, great. All right. Now we will talk about other special cases also. So one very complex case that we sometimes encounter is two blocks connected to a spring. Okay, so if this thing is set into motion, then you have to find the time period of the SHM. Okay, so let's see how you would have analyzed this. Hmm. So let's imagine that you displaced one block and extended, let's say, the spring by some amount and left it. Okay, you stretch this and left it. If you stretch it and left it, you realize, assuming of course there is no friction here, assuming mu here is 0. So when you stretch this system and leave it, there is no external force. Since there is no external force, so initial momentum, which is 0, will always remain 0. Okay, so I can say since there is external force, total momentum of system is constant, which is 0. Right, and now to analyze these methods, you have two methods of analyzing SHM situations: the force method and the energy method. Take both SHM equations, write third equation of the resultant, compare with the given equation, gives a resultant that can be analyzed to calculate energy. Something like this, sir. Yes, something like this. Okay, that is, yes, something that I wanted to say. So now here to analyze the time period of this, again, as I told you, there are two methods, force method and the energy method. Now it turns out whenever springs are involved, and in cases like this, the energy method is easier to analyze. Okay. Now let's imagine that at any instant during the motion, let's imagine that the this mass is moving in this direction with some v1, and this mass is moving in this direction with v2. Now I hope hello Suchir, how are you? I hope you do realize that both these masses have to move in the opposite directions to ensure that the momentum is zero, right? And at this time, let's imagine that the spring is stretched by some x. So what I can say is total energy of the system. Energy of the system. How can I write the total energy? So let's imagine this was the so one block is moved away by x1 from its mean, and this guy has moved away from x2 from its mean, and then at this instant these two have these velocities. So where will the mean position be? First of all, the mean position will be at the relaxed length. By definition, the mean position is when the system is in equilibrium, when the net force on the system is zero. Okay. So for individual masses, the equilibrium positions would be the relaxed length. Okay. So assuming that from the relaxed length position of the spring, the mass m1 has shifted by x1 and mass m2 has shifted by x2. At this instant, what is the energy? Energy is going to be half m1 v1 square plus half m2 v2 square plus half kx square. So how much would the spring have gotten stretched by now? X1 plus x2, correct? Okay. Hmm. Okay, maybe I forgot to upload that. Okay, I'll upload it soon. Okay. Okay, I hope you guys understand what I'm trying to do here. So I imagine that some relaxed position, this guy has shifted by x1 and this guy has shifted by x2. So the spring would have totally gotten stretched by x1 plus x2. And at these distances, I have imagined that the speeds are m1, m1 is moving with v1 and m2 is moving with v2. Okay, now I know since there is no dissipative force, so the total energy should be conserved. So what is d e by dt going to be? So that is going to be m v1 dv1 by dt plus m2 v2 dv2 by dt plus x1 plus x2 in, and now you would have had 3x1 by dt plus dx2 by dt, correct? And this would have been equal to 0 by energy conservation. Okay. Okay, so turns out no, energy method would be longer. I think the force method would be easier for this. Okay, never mind, never mind. Yeah, the force method would have been so much easier. Yes. Anyhow, we can still solve this using this also. Now you also know m1 v1 will be equal to also 1 v1. So what you will realize is when I equate this to 0, this will go, this will go. Okay. Now I can also relate these x1s. Okay, and I can say Not yet, not yet. So let me just tell you that v1 by dt plus v2 by dt on v1 would be plus a x1 plus x2. Then here you have v1 plus this is equal to 0. Okay, so what is the moment of inertia of an L-shaped rod about an end? So just add the moment of inertia of the two rods. That's it. Very very simple. इसमें क्या है? ये आपका एल शेप्ड रॉड हो गया. ठीक है, आपको इस एंड पे मान लो निकालना है. ठीक है, तो एक तो इसका आएगा मोमेंट ऑफ इनर्शिया और एक इसका आएगा. तो इसका मोमेंट ऑफ इनर्शिया आपको पता है 1/3 ml². ठीक है, इसके लिए क्या करोगे, इसके सीएम के अबाउट निकाल लो और इधर शिफ्ट कर दो. ये अगर x है और ये m डैश l डैश है तो प्लस आप क्या करोगे 1/12 डैश l डैश स्क्वायर प्लस डैश x स्क्वायर. खत्म. ये आ गया मोमेंट. समझ गए. हाँ, सो क्या हुआ, सिंगल रॉड को दो रॉड की तरह ट्रीट कर लो. दो रॉड की तरह ट्रीट कर लो, m/2 मास कर लो. इट्स वन एंड सेम थिंग, राइट? व्हाट डज इट मैटर? राइट. करके दिखाऊं क्या पूरा? हम्म. टेल मी. ओके. काम कर करके देख लेते हैं. लेट्स ट्राई एंड सी व्हाट यू ट्राई. ओके. हम्म. ओके. Let's say let's you had this of length L, total mass M, which is bent at the midpoint to form an L. So can I say this is m/2 L/2? This is also m/2 L/2. Correct? Now imagine you had an axis passing through this. Axis passing through this end. The axis is perpendicular to this. So about the axis, first I need to calculate the moment of inertia of this part, and then I need to calculate the moment of inertia of this part. Okay, so let's call this part number 1. Let's call this part number 2. So for part number 1, I already know the moment of inertia, है ना? So I1 would be equal to 1/3 to m/2 to L/2 whole square, correct? So that is by 3 into ml square over, so it would have been 4, 4 into 2, 8, 8 into 3, 24. So that is I1, correct? Now let's talk about I2. For this, I know the moment of inertia about an axis passing through the CM. And all I need to do is find this distance d. So this distance d, would that be, can I say that d square would be equal to L/2 whole square plus L/4 whole square? So d square would be essentially L square times 1/4 plus 1/16. That is, square is 5/16 L square. correct? Pythagoras theorem. Okay, so I got d square. Now I know what is I2 about this axis. So about this axis, I2 would be equal to 1 by 12 by 2 to L by 2 whole square, which is the I about the CM axis, plus md square. M is m by 2 to d square, which is 5 by 16 L square. ठीक है भाई, तो ये कितना हुआ, एम एल स्क्वायर कॉमन ले लो, ये हुआ 4 इंटू 2 8, 8 इंटू 1 बाई 12 प्लस यहाँ से क्या आया 5 बाई 32। ठीक है भाई, तो ये क्या आ गया, सो 32 में से 8 कॉमन ले लेते हैं, 12 बाई 8 कॉमन आया 1 बाई 12, 5 बाई 4 और कॉमन ले लो, एलसीएम ले लो, क्या आ गया 16 बाई 8 स्क्वायर, ये आपका 4 ml square by 6। ठीक है, yeah, what happened, am I not audible? सुनाई दे रहा है? So अभी तक so far we have this, okay, so ml square by 6, that is I2, so net I जो होगा, net I, what will that be, net I would be I1 plus I2, okay, which is going to be, first I had ml square by 24 plus ml square by 6, 24 LCM ले लो और ये हो गया 5 by 24 square, so that is the answer। ठीक है, देख लो भाई, ठीक है, तो बड़ा करके भी दिखा देता हूँ। क्या कहाँ दिया है, ml square by 6, ओके, भाई जो आपने सवाल पूछा है उसका ये होगा, खत्म बात। मुझे नहीं पता कौन सी बुक पढ़ने लग गए हो, ये गलत गलत चीजें लिखी हुई हैं। ml स्क्वायर बाय 6 तो अकेले इस पार्ट का आ रहा है, उसमें ml स्क्वायर बाय 24 भी तो जोड़ोगे। ठीक है, पहले तो ढंग की बुक्स पढ़ा करो यार, कौन सी बुक्स पढ़ते रहते हो। ओके ओके, कमिंग बैक टू दिस, तो यहाँ क्या हो रहा था, क्या हो रहा था, ओके, हाँ, नाउ ऑल आई नीड टू डू इज रिलेट दीज टू। हाँ ठीक है, प्लस पे फोटो भेजना, रिलेट दीज टू, तो आई नो 1x1 equals m2x2। Okay, so I need to convert everything into one variable, okay, so from here what I will realize is that I can write x2 as m1 by m2 x1. Similarly, 1 v1 to m2 v2. From here I can rewrite v2 as m1 by m2 1, and also with the help of this I can also rewrite a2 would be 1 over m2 a1. So let's replace all these values here. I can say a1 plus this would be m1 over m2 1 v1 plus a times I will write x1 plus m1 over m2 x1. Here I will have v1 plus 1 over 0. Okay. So yeah, I took the longer approach, the energy approach. I'll solve this using the force method also. That will be easy. Okay, okay, no problem. Okay, all right. So now let's take a1 common from here. So if I take a1 common from here, let's see what I'm getting. I'm getting a1 1 plus 1 by m1 v1 plus, again here I'm taking x1 and v1 common. Okay, x1 v1. Then also I'm getting 1 plus m1 by m2 whole square. In fact, I'm getting equals 0. Correct. So this will get removed. And now I will realize a1 into m1 v1 equals minus times k x1 and v1, and then I will have m1 plus m2 over m1 m2. So I will multiply this by m1, and here I will get m1 m2. This and this also gets cancelled, and finally I have a1 equals minus k times a over mu. We write this as x1. Okay. So, sir, do you live in Mahipalpur? Yes, I live near Mahipalpur. I live in Vasant Kunj. Okay, okay, no problem, Lokesh. So I live in Vasant Kunj actually, which is right next to the right next to Mahipalpur, very near the airport. Okay, so yes, you can probably keep hearing all the planes passing through. Okay, so obviously the time period, this is omega square, and obviously the time period now becomes 2 pi root mu by k, where mu is called the reduced mass of the system, and it is m1 m2 over m1 plus m2. Okay, so that is the first method of solving this energy method. Yeah, unfortunately, I took up that method first, which is the longer method, enough. But we got the answer finally. This is how you get the answer of this. Now, you could have also analyzed this using the force method. Turns out would have been simpler using force method. Again, assume that this block is away from its equilibrium position by some x1. Okay, and now this is moving with some v1. Then the force acting on it must be equal to kx. Correct? Kx force will act. So can I say m1 times d2 x1 by dt2 would be equal to minus k times x. Okay, and x can be written as x1 plus x2, where this guy has shifted by x2. So I can rewrite this as m1 d2 x1 by dt2 was minus k times x1 plus x2. And again, you can write m1 x1 would be equal to m2 x2 because the CM position cannot change. So x2 can be written as m1 x1 over m. So if you replace that, you will get d2 x1 by dt2 is equal to minus k, and of course, you have m1 plus 2 over m1 m2 x1. So again, you're getting the same differential equation, okay, which would have given you the same answer. Yeah. So my Palpur is right next to Vasant Kunj also. The right next to my Palpur is Vasant Kunj. So that is where I live. So you get this differential equation. Of course, you have this time period. Okay, so that is how you would have analyzed a two block system. Okay. Okay. I'm sure you can continuously keep hearing the planes passing by. That's a slight problem living in here. Okay. Now, another special case that I wanted to discuss was placing one block over the another during SHM. Okay, so this is another kind of problem that has been asked often. Okay, so imagine if this is a block which is performing SHM, and during its motion, you place this other block on it gently, and such that the moment you keep these two stick together. Okay, so in such a question, small m small m is gently placed over capital M during its SHM. Okay, and the two masses stick together. So there are usually two conditions that are asked of you. One, the mass is gently kept at the extreme. Second, the mass is placed at capital M at its mean. So generally these two cases are asked. I'll tell you these two cases, and then you can figure out what other cases might also look like. So let's talk about case number one. Case one, small m is placed over capital M when capital M is at its extreme. Okay. Now, in this case, what you will realize is at the extreme, the mass capital M would be at rest, right? Capital M is at rest. Now, when you place small m over it right now, so what will happen? It is already at its extreme and it will try to go back. So the amplitude you realize remains unchanged, of course. Okay. So in this case, the amplitude remains unchanged. Okay, what happens to the frequency? Omega, however, will change. Omega is root k by m. So reduces. And what about the total energy? Energy, you realize initially was half capital M omega square a square omega final omega initial square a square. Omega initial was half capital M a by m a square. Like this. And finally also you will realize you will get that only half to m plus m into omega square, which will be again k over m plus m a square. So what you realize is both half ka square in both the cases. So the energy is not lost. Okay, so in such a case, the amplitude remains the same, the omega reduces, and there is no loss of energy. Okay, now let's talk about the next possible case. Case 2, small m is placed over capital M when is at its mean. So in this case, what happens is your home is near to DAV school. Okay, so no, it is close to another school, Ryan International School. You can Google that. So that is very near my school, uh, near my house. I don't know about the DAV school. Okay, all right. So again, and now what happens is imagine capital M was moving to the side with was at its mean and was moving to the side with a velocity v1, the initial. And now you place that block over this. So you realize since there is no external force because you gently put it, so due to momentum conservation, the velocity will reduce. Here, due to momentum conservation, so let's call this v. What we will realize is that m v naught would be equal to m plus m v. Okay, so you can find the new v. So nu v would be equal to m v naught over m plus m. So obviously, because of this, the amplitude will also change. So this is the mean position velocity. The omega naught was a over capital M. Omega was a root of k over capital M plus M. You also know V naught was omega naught A, and V would be omega times A. So from here you can find out the new amplitude also. You can say that M plus would be equal to the equal to nu omega, which is root k over m plus m times k. Okay, now instead of v naught, I will again write omega naught a naught. This will become m by m plus 2 omega naught, which was root k over m, to naught equals root k over m plus m When I compare these, so this and this will get cancelled. This will result in a root here. This will result in a root here. So what I realize is the amplitude also decreases now. Okay, so what happens to the new amplitude? So in this case, the amplitude decreases, the velocity decreases, the omega decreases, everything is decreasing. So what do you think happens to the energy? Till now, I haven't seen Delhi, sir. So whenever I visit, I will meet you. Definitely, definitely, and you're most welcome. I would be glad to meet you. Okay, so how about energy? Energy E naught would be half omega naught square A naught square. Right? That would have been half A naught square. And what about energy final? Energy final would be half. Again, you would have had K and a new A squares over M plus M square. That is what you would have had as the final energy. So final energy also decreases. So where is the energy going? Where did this energy go? So you realize the difference I notice is that when I placed the block at its extreme, then the total energy remains the same. The amplitude remains the same. The omega changes, but so does the total mass of the system. So because of that, the term m omega square remains the same. Correct. Here there is no loss of energy, and here there is loss of energy. So the reason for that is, imagine what is happening is that when you are putting this small m over this m, so you realize this was already moving with V naught. So there would have been friction between them. Okay, this friction would have acted on this small m like this, and this all capital M like this. And there would have been some negligible displacement, relative displacement. And it is the work done by that friction that is reducing the energy. Okay, so friction, frictional force does the negative work to reduce the energy. Okay, so that is the difference. When you are putting it at extreme, there was no motion of capital M, so small m again would have not had a tendency of slipping, so there would not have been any friction. Okay, on in the mean position, there would have been a tendency of slipping, so the friction would have come into play, and that would have done negative work and caused the loss of energy. Okay, so again, I hope that is clear. Okay, next here is a challenge problem for you, Bill. Okay, this is another great problem. Okay, this is a challenge problem that I leave you with. Okay, this is a wonderful problem. A mass of small m 0.15 kg slides in a circle of radius 20 centimeter on a frictionless table while attached to another hanging mass capital M of 2.5 kg by an idle string passing through a hole in the table. See the figure? Okay, and you have to find the angular velocity of small m for which capital M is at rest. So with what angular velocity should this be rotating, so that it can hold this m in equilibrium, correct? So first you have to find that. Second, if the capital M is pulled slightly down and released, then prove that the subsequent motion of capital M will be SHM, and also find its time period. Okay, so again, this is a wonderful problem, very interesting and tough problem. I would like you guys to try this, and we will discuss this tomorrow. Okay. So with that, let's bring our today's session to an end. So that is everything that I wanted to discuss about SHM. So that concludes our discussion of SHM. From tomorrow, we will start our discussion on waves. Okay, again, waves is a very, very important topic. Please make sure to attend the lectures on waves also. Okay. Now, before I leave you, let me remind you, if those of you who are planning to get their Unacademy subscriptions but still haven't gotten them, so this is how you should go about it. So all you need to do is install the Unacademy app, go to the plus section of the app, select your goal as IIT and click on that subscription button. Okay, that is how easy it is. Next, when you do that, you will be redirected towards the payment page where you will find a box which will say, do you have a code? So there you can enter this code RD Life. This code will give you a 10% off on all your subscription fees. And now you can choose from two kinds of subscriptions, Plus and Iconic. The fees of various plans as follows. You'll also realize when you click on Proceed to Pay, you will get a lot of no-cost EMI options also to choose from, which will help you reduce the burden of this payment. Okay. Next, those of you who don't know what the iconic subscription is, so let me quickly tell you about that. So the iconic subscription is something that will take your JEE preparation to the next level. And how does it do that? So you'll be allotted personal coaches from our team of experts. Okay, these personal coaches will closely mentor you and monitor your performance throughout your JEE journey. Okay. Next, you will also get a chance to attend a lot of IIT JEE workshops. You will receive expert guidelines from time to time. You will be getting a study planner and, of course, regular test and answer sessions. So, with all these features, along with all the plus benefits, you will power through your IIT JEE journey. Okay. Next, students who have just come into class 11th and are looking for a single one-stop solution for all their preparation worries, no need to think about too much. Now you can go for these combo subscriptions that Unacademy is now offering you. So Unacademy is now offering you a combo subscription which takes care of your class 11 CBSE, class 12 CBSE, your boards, and your IIT JEE preparation, both in mains and advanced. So with these combo subscriptions, all your study worries are taken care of. So there are four kinds of combos which are available for you to choose from. The first combo offers you the iconic subscription for IIT JEE and the plus subscription for class 11 and 12. This combo starts at around 4,600 a month. The second combo offers you the iconic subscription for all three. This combo starts at around 5,500 a month. Then you have the third combo, which starts at 3,000 roughly a month, and this provides you the plus subscription for all these three. And finally, you have a combo which offers you the plus subscription for IIT JEE and iconic subscription for 11th and 12th. This starts at around 3,900 a month. So now you can choose any of these combos that suits your preparation needs and then leave all your study worries behind. Okay. Now this is a list of the upcoming tests in January. So make sure you're not missing out on any of these. 31st January is the date for the next Unacademy Combat event. Next race test is going to happen on the 24th of Jan. Now AIM advanced papers are happening every Saturday, and unique DPPs are being discussed from Monday to Thursday every week. Okay. Make sure you're not missing out on any of these. Also, a lot of new batches that are emerging and a lot of other information is available in the description box below. So do check out the links in the description box. That will give you a lot of other relevant information also. Now, if you like today's session, then do not forget to press the like button and share it with as many people as you can. So make sure that more and more students can benefit from this free quality content being provided by Unacademy on this particular channel. If you're new to this channel, don't forget to subscribe and do not forget to press the bell icon. Okay. Now, the PDF of all these notes used in today's lecture, slides used in today's lectures would be available for download very, very soon. Okay, and now you can also join us on the Telegram app using this link. So this will ensure that you're getting timely notifications of all the lectures and sessions happening here on this channel of YouTube. Okay. Next, that is where I wrap up today's discussion. Before I leave you, let me remind you one last time, this is my code RD Live. So if you like my lectures, if you'd like to enroll in my courses on Plus, then this is the code you can get your subscriptions with and enjoy a 10% off on all your subscription fees. All right. So that, let's wrap up today's session. We will continue our discussion tomorrow at 4 again, where in fact we will start our discussion on waves. So till then, you go through this lecture. Try the challenge problem, try and leave the answers in the comment section. And if you have any queries, then you can ask away those tomorrow. Okay. So till then, I'll then see you tomorrow then at 4. And you guys till then keep practicing hard and keep studying hard and take good care of yourselves. Bye-bye.